Just-in-time is a production strategy that strives to improve a business return on investment by reducing in-process inventory and associated carrying costs. Just-in-time is a type of operations management approach which originated in Japan in the 1950s. It was adopted by Toyota and other Japanese manufacturing firms, with excellent results. Toyota and other companies that adopted the approach ended up raising productivity significantly. To meet JIT objectives, the process relies on signals or Kanban between different points, which are involved in the process, which tell production when to make the next part. Kanban are usually tickets but can be simple visual signals, such as the presence or absence of a part on a shelf. Implemented correctly, JIT focuses on continuous improvement and can improve a manufacturing organization's return on investment, quality, and efficiency. To achieve continuous improvement, key areas of focus could be flow, employee involvement and quality. JIT relies on other elements in the inventory chain as well. For instance, its effective application cannot be independent of other key components of a lean manufacturing system, or it can end up with the opposite of the desired result. In recent years, manufacturers have continued to try to hone forecasting methods such as applying a trailing 13-week average as a better predictor for JIT planning. However, some research demonstrates that basing JIT on the presumption of stability is inherently flawed. Philosophy: the philosophy of JIT is simple: the storage of unused inventory is a waste of resources. JIT inventory systems expose hidden cost of keeping inventory, and are therefore not a simple solution for a company to adopt it. The company must follow an array of new methods to manage the consequences of the change. The ideas in this way of working come from many different disciplines including statistics, industrial engineering, production management, and behavioral science. The JIT inventory philosophy defines how inventory is viewed and how it relates to management. Inventory is seen as incurring costs, or waste, instead of adding and storing value, contrary to traditional accounting. This does not mean to say JIT is implemented without an awareness that removing inventory exposes pre-existing manufacturing issues. This way of working encourages businesses to eliminate inventory that does not compensate for manufacturing process issues, and to constantly improve those processes to require less inventory. Secondly, allowing any stock habituates management to stock keeping. Management may be tempted to keep stock to hide production problems. These problems include backups at work centers, machine reliability, process variability, lack of flexibility of employees and equipment, and inadequate capacity. In short, the just-in-time inventory system focuses in having the right material, at the right time, at the right place, and in the exact amount euro, without the safety net of inventory. The JIT system has broad implications for implementers. Transaction cost approach: JIT helps in keeping inventory to minimum in a firm. However, a firm may simply be outsourcing their input inventory to suppliers, even if those suppliers don't use just-in-time. Newman investigated this effect and found that suppliers in Japan charged JIT customers, on average, a 5% price premium. Environmental concerns: during the birth of JIT, multiple daily deliveries were often made by bicycle. Increased scale has required a move to vans and trucks. Kusumano highlighted the potential and actual problems this causes with regard to gridlock and burning of fossil fuels. This violates 3 JIT waste guidelines: to wasted in traffic jams, inventory specifically pipeline inventory, scrap fuel burned while not physically moving, price change. Because just-in-time manufacturers do not store raw materials, they can be affected more drastically by the effects of changing prices. Quality volatility: JIT implicitly assumes that input parts quality remains constant over time. If not, firms may hoard high-quality inputs. As with price volatility, a solution is to work with selected suppliers to help them improve their processes to reduce variation and costs. Longer-term price agreements can then be negotiated and agreed on quality standards made the responsibility of the supplier. Fixing up of standards for volatility of quality according to the quality circle: Demand stability. Car marker highlights the importance of relatively stable demand, which helps ensure efficient capital utilization rates. Car marker cost production. Supply stability. In the U.S., the 1992 railway strikes caused General Motors to idle a 75,000-worker plant because they had no supply. JIT implementation design. Based on a diagram modeled after the one used by Hewlett-Packard, a unregistered trademark Boise plant to accomplish its JIT program. 1. F design flow process. A F redesign relayout for flow, a L reduce lot sizes, a O link operations, a W balance workstation capacity, a M preventive maintenance, a S reduce setup times. 2. Q total quality control. A C worker compliance, a I automatic inspection, a M quality measures, a M fail-safe methods, a W worker participation. 3. S stabilize schedule. A S level schedule, a W establish freeze windows, a UC underutilized capacity. 4. K Kanban pull system. A D demand pull, a B backflush, a L reduce lot sizes. 5. V work with vendors. A L reduce lead time, a D frequent deliveries, a U project usage requirements, a Q quality expectations. 6. I further reduce inventory in other areas. A S stores, a T transit, a C implement carousel to reduce motion waste, a C implement conveyor belts to reduce motion waste. 7. P improve product design. A P standard production configuration, a P standardize and reduce the number of parts, a P process design with product design, a Q quality expectations. Effects. A surprising effect of JIT was that car factory response time fell to about a day. This improved customer satisfaction by providing vehicles within a day or two of the minimum economic shipping delay. Also, the factory began building many vehicles to order, eliminating the risk they would not be sold. This improved the company's return on equity. Since assemblers no longer had a choice of which part to use, every part had to fit perfectly. This caused a quality assurance crisis, which led to a dramatic improvement in product quality. Eventually, Toyota redesigned every part of its vehicles to widen tolerances, while simultaneously implementing careful statistical controls for quality control. Toyota had to test and train part suppliers to assure quality and delivery. In some cases, the company eliminated multiple suppliers. When a process or parts quality problem surfaced on the production line, the entire production line had to be slowed or even stopped. No inventory meant a line could not operate from in-process inventory while a production problem was fixed. Many people in Toyota predicted that the initiative would be abandoned for this reason. In the first week, line stops occurred almost hourly. But by the end of the first month, the rate had fallen to a few line stops per day. After 6 months, line stops had so little economic effect that Toyota installed an overhead pull line, similar to a bus bell pull, that let any worker on the line order a line stop for a process or quality problem. Even with this, line stops fell to a few per week. The result was a factory that has been studied worldwide. It has been widely emulated, but not always with the expected results, as many firms fail to adopt the full system. The just-in-time philosophy was also applied to other segments of the supply chain in several types of industries. In the commercial sector, it meant eliminating one or all of the warehouses in the link between a factory and a retail establishment. Examples in sales, marketing, and customer service involve applying information systems and mobile hardware to deliver customer information as needed, and reducing waste by video conferencing to cut travel time. Benefits. Main benefits of JIT include, reduced setup time. Cutting setup time allows the company to reduce or eliminate inventory for changeover time. The tool used here is SMED. The flow of goods from warehouse to shelves improves. Small or individual piece lot sizes reduce lot delay inventories, which simplifies inventory flow and its management. employees with multiple skills are used more efficiently. Having employees trained to work on different parts of the process allows companies to move workers where they are needed. Production scheduling and work hour consistency synchronized with demand. If there is no demand for a product at the time, it is not made. This saves the company money either by not having to pay workers overtime or by having them focus on other work or participate in training. Increased emphasis on supplier relationships. A company without inventory does not want a supply system problem that creates a part shortage. This makes supplier relationships extremely important. Supplies come in at regular intervals throughout the production day. Supply is synchronized with production demand and the optimal amount of inventory is on hand at any time. When parts move directly from the truck to the point of assembly, the need for storage facilities is reduced. Minimizes storage space needed. Smaller chance of inventory breaking expiring. Problems. Within a JIT system, just-in-time operation leaves suppliers and downstream consumers opening to supply shocks and large supply or demand changes. For internal reasons, Ono saw this as a feature rather than a bug. He used an analogy of lowering the water level in a river to expose the rocks to explain how removing inventory showed where production flow was interrupted. Once barriers were exposed, they could be removed. Since one of the main barriers was rework, lowering inventory forced each shop to improve its own quality or cause a hold-up downstream. A key tool to manage this weakness is production leveling to remove these variations. Just-in-time is a means to improving performance of the system, not an end. Very low stock levels means shipments of the same part can come in several times per day. This means Toyota is especially susceptible to flow interruption. For that reason, Toyota uses two suppliers for most assemblies. As noted in Leica, there was an exception to this rule that put the entire company at risk because of the 1997 Aisin fire. However, since Toyota also makes a point of maintaining high-quality relations with its entire supplier network, several other suppliers immediately took up production of the Aisin-built parts by using existing capability and documentation. Within a raw material stream, as noted by Leica and Womack and Jones, it ultimately would be desirable to introduce synchronized flow and link JIT through the entire supply stream. However, none followed this in detail all the way back through the processes to the raw materials. With present technology, for example, an ear of corn cannot be grown and delivered to order. The same is true of most raw materials, which must be discovered and/or grown through natural processes that require time and must account for natural variability in weather and discovery. The part of this currently viewed as impossible is the synchronized part of flow and the linked part of JIT. It is for the reasons stated raw materials companies decouple their supply chain from their clients' demand by carrying large finished goods stocks. Both flow and JIT can be implemented in isolated process islands within the raw materials stream. The challenge becomes to achieve that isolation by some means other than carrying huge stocks, as most do today. Because of this, almost all value chains are split into a part made to forecast and a part that could, by using JIT, become make-to-order. Historically, the make-to-order part has often been within the retailer portion of the value chain. Toyota took Piggly Wiggly's supermarket replenishment system and drove it at least halfway through their automobile factories. Their challenge today is to drive it all the way back to their goods inwards dock. Of course, the mining of iron and making of steel is still not connected to an order for a particular car. Recognizing JIT could be driven back up the supply chain has reaped Toyota huge benefits and a dominant position in the auto industry. Note that the advent of the mini-mill steelmaking facility is starting to challenge how far back JIT can be implemented, as the electric arc furnaces at the heart of many mini-mills can be started and stopped quickly, and steel grades changed rapidly. Oil, it has been frequently charged that the oil industry has been influenced by JIT. The argument is presented as follows: the number of refineries in the United States has fallen from 279 in 1975 to 205 in 1990 and further to 149 in 2004. As a result, the industry is susceptible to supply shocks, which cause spikes in prices and subsequently reduction in domestic manufacturing output. The effects of Hurricanes Katrina and Rita are given as an example. In 2005, Katrina caused the shutdown of 9 refineries in Louisiana and 6 more in Mississippi, and a large number of oil production and transfer facilities, resulting in the loss of 20% of the U.S. domestic refinery output. Rita subsequently shut down refineries in Texas, further reducing output. The GDP figures for the third and fourth quarters showed a slowdown from 3.5% to 1.2% growth. Similar arguments were made in earlier crises. Beside the obvious point that prices went up because of the reduction in supply and not for anything to do with the practice of JIT, JIT students and even oil and gas industry analysts question whether JIT as it has been developed by ONO, Goldratt, and others is used by the petroleum industry. Companies routinely shut down facilities for reasons other than the application of JIT. One of those reasons may be economic rationalization, when the benefits of operating no longer outweigh the costs, including opportunity costs, the plant may be economically inefficient. JIT has never subscribed to such considerations directly. Following Waddell and Bodek, this ROI-based thinking conforms more to Brown-style accounting and Sloan management. Further, and more significantly, JIT calls for a reduction in inventory capacity, not production capacity. From 1975 to 1990 to 2005, the annual average stocks of gasoline have fallen by only 8.5% from 228,331 to 222,903 barrels to 208,986. Stocks fluctuate seasonally by as much as 20,000 barrels. During the 2005 hurricane season, stocks never fell below 194 million BBL, while the low for the period 1990 to 2006 was 187,017,000 BBL in 1997. This shows that while industry storage capacity has decreased in the last 30 years, it hasn't been drastically reduced as JIT practitioners would prefer. Finally, as shown in a pair of articles in the Oil and Gas Journal, JIT does not seem to have been a goal of the industry. In Wagespock and Cantor, the authors point out that JIT would require a significant change in the supplier-refiner relationship, but the changes in inventories in the oil industry exhibit none of those tendencies. Specifically, the relationships remain cost-driven among many competing suppliers rather than quality-based among a select few long-term relationships. They find that a large part of the shift came about because of the availability of short-haul crudes from Latin America. In the follow-up editorial, the Oil and Gas Journal claimed that casually adopting popular business terminology that doesn't apply had provided a rhetorical bogey to industry critics. Confessing that they had been as guilty as other media sources, they confirmed that it also happens not to be accurate. Business models following similar approach, vendor-managed inventory. Vendor-managed inventory employs the same principles as those of JIT inventory, however, the responsibilities of managing inventory is placed with the vendor in a vendor-customer relationship. Whether unregistered trademark SA manufacturer managing inventory for a distributor, or a distributor managing inventory for their customers, the management role goes to the vendor. An advantage of this business model is that the vendor may have industry experience and expertise that lets them better anticipate demand and inventory needs. The inventory planning and controlling is facilitated by applications that allow vendors access to their customers' inventory data. Another advantage to the customer is that inventory cost usually remains on the vendor's books until used by the customer, even if parts or materials are on the customer's site. Customer-managed inventory. With customer-managed inventory, the customer, as opposed to the vendor in a VMI model, has responsibility for all inventory decisions. This is similar to JIT inventory concepts. With a clear picture of their inventory and that of their supplier unregistered trademark S, the customer can anticipate fluctuations in demand and make inventory replenishment decisions accordingly. Early use of a JIT system. A type of JIT was used successfully in the UK by Perkins to supply F3 engines to Ford from 1957 until 1964. See also, backflush accounting, CONWIP, demand flow technology, industrial engineering, inventory proportionality, just-in-case manufacturing, just-in-sequence, lean consumption, lean manufacturing, liquid logistics, organizational capital, real-time enterprise, theory of constraints, total quality management, vendor-managed inventory, references. Further reading, Schonberger, Richard J., Japanese Manufacturing Techniques, 9 Hidden Lessons and Simplicity, Free Press, ISBN 0-02-929100-3, editorial, The Inventory Landmine, Oil and Gas Journal, Vol 94, No. 29, July 15, 1996. Flinchbaugh, Jamie and Carlino, Andy, The Hitchhiker's Guide to Lean, Lessons from the Road, SME, ISBN 0-87063-831-6, Goldratt, Eliyahu M. and Fox, Robert E., The Race, North River Press, ISBN 0-88427-062-9, Hirano, Hiroyuki and Makota, Furuya, JIT is Flow, Practice and Principles of Lean Manufacturing, PCS Press, Incorporated, ISBN 0-9712436-1-1, Leica, Jeffrey, The Toyota Way, 14. Management Principles from the World's Greatest Manufacturer, 1st edition, McGraw-Hill, ISBN 0-07-139231-9. Management Coaching and Training Services. The Just-in-Time Approach. Retrieved June 19, 2006 from the World Wide Web. 1. Ono, Teiichi, Toyota Production System, Beyond Large-Scale Production, Productivity Press, ISBN 0-915299-14-3, Ono, Teiichi, Just in Time for Today and Tomorrow, Productivity Press, ISBN 0-915299-20-8, Waddell, William, and Bodek, Norman, The Rebirth of American Industry, PCS Press, ISBN 0-9712436-3-8, Wakespock, Kevin, and Cantor, Brian, Oil Inventories should be based on margins, supply reliability, Oil and Gas Journal, Vol 94, No. 28, July 8, 1996. Womack, James P. and Jones, Daniel T., Lean Thinking, Banish Waste and Create Wealth in Your Corporation, revised and updated, Harper Business, ISBN 0-7432-4927-5. Womack, James P., Jones, Daniel T., and Roos, Daniel, The Machine That Changed the World, The Story of Lean Production, Harper Business, 2003, ISBN 0-06-097417-6. Condi, Alan T. Fordson Dexter 957 E's 1957-1964 ISBN 0-907742-71-8.